So I will read out the problem first. Consider the following problem faced by a production planner of a soft drink plant. He has two bottling machines A and B. A is designed for 8-ounce bottles and B for 16-ounce bottle. However, each can also be used for both types of bottles with some loss of efficiency. The manufacturing data is given. Two machines A and B, and how much time it takes for manufacturing 8-ounce bottle. In machine A, if you manufacture 8-ounce bottle, there are 100 bottles per minute. If you are using machine B to manufacture 8-ounce bottle, that gives an output of 60 bottles per minute. Next one, if you are using if you manufacture 16-ounce bottle using machine B, you get 45 bottles per minute. Whereas if you are using machine B to manufacture 16-ounce bottle, then you get 75 per minute. You have seen the efficiency is high when you are using machine A for 8 ounce and machine B for 16 ounce. Output will be more. Their machines can run for 8 hours per day, 5 days per week. The profit on an 8-ounce bottle is rupees 1.5 and on a 16-ounce bottle rupees 2.5. Weekly production of the drink cannot exceed 3 lakhs. The market can also absorb 25,000 8-ounce bottle and 7,000 16-ounce bottle per week. The planner wishes to maximize his profit, subject of course to all the production and marketing restrictions. Formulate this problem as an LP model to maximize total profit. So this problem is again simple problem. If we need to manufacture 8-ounce bottle and 16-ounce bottle using machine A and B. So machine A gives you some output. That means some units of 8-ounce bottle and some units of 16-ounce bottle, which we need to calculate. Machine B also, because of our demand and various constraints, we use machine B also to manufacture some 8-ounce bottle and 16-ounce bottle. So the output will be different. Some unit of output, some output will be 8-ounce bottle and some output will be 16-ounce bottle. What we are going to do is we are just arbitrarily giving some variable associated with these outputs. So I am just giving the output like this. This is 8-ounce bottle and this is 16-ounce bottle and this is machine A and machine B. So machine A, how many 8-ounce bottle? X1. Machine A gives you X2 16-ounce bottle. And machine B gives you X3 8-ounce bottle and machine B gives you X4. This is for your understanding, because without this we cannot solve this problem. There are two machines and two outputs. So we need to have 4 variables. There is no other option. And once that is done, the whole problem is resolved. So I am just making the table. What are the products? 8-ounce bottle. Next one is 16-ounce bottle. So, and this is first machine A. So number of units X1 and X2. This is available. And machine B gives you how much? Number of units X3 and X4. You can give Y1, Y2, any variable you can, any arbitrarily, any alphabet you can use for describing the variable. Next one is the profit. What is the profit? 8 ounce bottle, what is the profit? 1.5. Agree? And 16 ounce bottle, it is 2.5. So I am just giving 1.5 rupees here and 2.5 rupees as profit. Now, the machine A, what is the production time? Production time constraint. Machine A, 100 bottle per minute. That means how many to make one bottle? What is the time? 1 by 100. That is 1 by 100. What is that mean? To manufacture 1 unit of 8 ounce bottle using machine A, you would require 1 by 100 of a minute. Agree? And here it is 45 per minute. That means to manufacture 16 ounce bottle using machine A, you need 1 by 45 of minutes. That is what the meaning. So 1 by 45. To manufacture 1 unit of 16 ounce bottle using machine A require 1 by 45 minutes. So this is all in minutes. I am just writing in minutes. And the production time using machine A, and this is using next one machine B. Machine B now. I am using machine B to manufacture 1 unit of 8 ounce bottle. So 60 bottles per minute. So 1 by 60 minutes for 1 bottle. And 75 bottles per minute. So to make 1 unit of 16 ounce bottle using machine B, it is 1 by 75. And availability is given. Eight hours per day, 5 hours per week. So we have a schedule of 5 hours. So it is 40 hours, and this is in minutes. So 40 into 60, that is equal to 2400 minutes. Because both sides of the equation you should have the same unit. You agree with me? Here it is also same, correct? No? 2400 minutes. Because both the machine work for the same time during the week. Now it is easier to formulate the problem. What is the thing? Profit maximization, objective function. Objective function is profit maximization. Maximize profit. Z is equal to, you have 8 ounce bottle first. How many 8 ounce bottle? X1 plus X3 8 ounce bottle. So X1 plus X3. 1 unit profit is 1.5. So total profit will be 1.5 into total number of 8 ounce bottle. Plus you have how many units of 16 ounce? X2 plus X4. And then you have to multiply by 2.5. Why? Because 1 unit of 16 ounce bottle, the profit is 2.5. So X2 plus X4, that is the total number of 16 ounce bottle is manufactured. So it is 2.5 into X2 plus X4. Next, production time. 1 unit of 8 ounce bottle from using machine A require 1 by 100. Correct? No? So first is time constraint or production constraint using machine A. So 1 by 100 into x1. Why? Because you made x1 unit using machine A. So 1 by 100 into x1 plus 1 by 45 into x2. Because you are using x2 units are manufactured using machine A. And total available time will be less than or equal to 2400 minutes. So this is the first constraint. This is one. This is machine A. Next, production constraint, time constraint 2. Machine B. 1 unit of 8 ounce bottle using machine B is 1 by 60. So x3 unit. So B is x3 unit. So into x3 plus 1 by 75 into x4. Why? Because we make x4 using machine B. We make x4 16 ounce bottle using the second machine. And total time availability is 2400. Now we have certain other things also. We can maximum produce how much? 3 lakhs. That means how many machines, how many bottles you manufacture? X1 plus, X2 plus, X3 plus, X4. That is the total number of this. That will be less than 3 lakhs, 300,000 bottles. And what is the 8 ounce bottle? 8 ounce bottle is X1 plus X3. X1 plus X3 will be less than or equal to how much? 25,000. That is maximum also 25,000. And similarly X2 plus X4 will be less than or equal to how much? 7,000. And over everything except non-negative constraint. X1, X2, X3, X4 are non-negative, greater than or equal to 0. Thank you.